Guys, welcome to the next lecture from Introductory Statistics. And today we will work on the concept of conditional probability. When you are assigning probabilities, what does it depend on? It depends on whatever you know in the experiment, right? So the probabilities assigned to various events really depend on what is known about the experiment when the assignment is being done, assignment of that probability. Now, in the process, say you get some additional information in your experiment subsequent to the initial assignment, some partial information, but which is relevant to the outcome of the experiment may become available to you. And think about it. Isn't it very obvious that it will have an impact on the probability that we have assigned? Such information may cause us to revise some of our probability assignments that we have done because the extra information is going to make such changes. Now, probability A when we write down, PA in general when we write down, this is an unconditional or the initial probability of event A. Now, what are we doing? Now we are examining. We would want to examine how the information that event B has occurred affects the probability that we have assigned to A. Does the probability now increases or decreases? We might want to know. For example, let's take a simple example here. Suppose A is an event that an individual having a particular disease in the presence of certain symptoms. And now, because we are talking about disease, we take a blood test. If a blood test is performed on the individual and the result is negative, let's take this negative result, negative blood test as event B. Now, if you get to know from the blood test that the result of the blood test is negative, now that will have an impact on the probability associated to this scenario. Then the probability of having the disease will change because the test is saying that it's negative. Blood test is negative, which would want me to believe that probably this person does not have the disease. But in terms of probability, that means I can say that the probability that this person has the disease, given that the test turned out to be negative, should be actually much lower than the probability that this person has disease without any condition. So probability A conditioned to B is written like this. Probability A conditioned to B, or we say given B. Probability A given B, it's the conditional probability of A given that the event B has occurred. In this question, this will turn into probability of having the disease given test is negative. Now think about it. If you consider probability of this person having a disease because this person has certain symptoms without taking up the blood test, you would feel that the probability is something point, say 80% chance, 70% chance. But the moment you take the test and the result is saying negative, what would you logically think? You will logically think that the probability of this person having the disease falls down to say 10-20%. I'm taking numbers just for clarification here. Let's take another example. So you should think in your mind, so does it mean that when I have an additional information the conditional probability would always be lower, or can it be greater also? Let's see. Suppose this time A is randomly selected student. The event A is associated to a randomly selected student at your university, obtained all desired classes during the previous term's registration cycle. Suppose probability A is not very large. Not everyone would have been, able to take all desired classes. However, suppose the selected student is an athlete who gets special registration priority. Suppose special registration priority is being given to athlete. And let's take this as event B. Then, what do you think will be the probability A conditioned to B or A given B in comparison to probability A? Then probability A given B, when you know this person, this student is actually an athlete and athletes have some special reservations, they get priority, okay, for registration, then that means the probability, given that this student is a sports person, the probability that this person gets all desired classes is much higher, must be substantially higher. Higher than probability just A, probability that this person is, unconditional, given this person is not an athlete, okay? So, which means that in this example, we saw that probability A condition to B turns out to be much higher than probability just A without this condition B. So, the conditional probability, it really depends on the additional information that you have. The conditional probability can be higher. The conditional probability can also be lower. Let's take another example for clarification. Complex components are assembled in a plant that uses two different assembly lines. So two different assembly lines or techniques are used, A and A dash. Line A uses older equipments than A dash, so it is slower relatively. On a given day, suppose line A assembled 8 components, of which 2 have been identified as defective. Now we will take this defective as event B. So B complement as non-defective. 2 are defective, 6 are non-defective. Whereas for A, 1 defective, 9 non-defective. So if I put this data out here, we have 2 assembly lines, line A and A dash, and we have divided the data in defective, non-defective, so B, B dash. So 2, 6 here, 1, 9 here. Suppose the sales manager is not aware of, all this information about the defective, non-defective information. Unaware of this information, the sales manager selects 1 out of the total 18 components. If you notice, there are 18 components, 8 from A and 10 from A dash. So sales manager selects 1 out of 18 components. Now, what is the probability that he has selected components from line A? It is the total number in line A upon the total number A, including A and A dash. So 8 upon 18, that is 0.44. However, if what he has selected, the chosen one, is a defective one, now B comes into the picture, because then B has occurred. B is defective has occurred. So the component you already know that is defective. If you know that it is defective, then the component has to be out of any one out of these three. Then under that situation, what is the probability that the component comes from A? It will clearly be 2 by 3 because there were two components, defective components in A. Okay. In other words, if you observe, what is this 2 and what is this 3? 2 by 3 could be interpreted as, this 2 can be interpreted as 2 by 18. 2 by 18 is what? 2 by 18 is the defective probability of defective from A. The probability of defective and from A. So you can interpret as probability A intersection B. As in it's coming from A and it is defective also. So there are two such components out of all the 18. Similarly, this 3 can be written as or can be expressed as, explained as 3 by 18. It is the total defective out of the 18. It is basically 3 are defective out of 18. So probability of A intersection B, you can call it the numerator, and the denominator probability B, probability of defective. And without mentioning this, we were easily able to say that, oh, it's going to be 2 by 3. Why did we say that? Because this time, what are we saying? We are saying what is the probability that the defective one is from A. That will be, there are two defective in A, and in total there are 3 defective. So therefore, you can define conditional probability for any two events A and B. Given that probability B is greater than 0, the conditional probability could be defined as the conditional probability of A conditioned to or given that B has occurred, written as probability A conditioned like a slash here, B is equal to probability A intersection B upon probability B. Reason you must have understood कि यहाँ पर आपको क्या चाहिए कि condition है probability B. तो आपका जो अब total outcome है, क्योंकि आपको पता है कि B हो गया है, तो आपका total outcome B बन जाएगा. और आपको क्या चाहिए? Probability A चाहिए given B. तो B तो हुआ है ना. So that means what you are looking for should be in A also and B also. That is why this is what you will get as the formula for conditional probability. Let's finally take another example to understand the situation better. Suppose that of all individuals buying certain digital cameras, 60% include an optional memory card in their purchase. 40% include extra battery and 30% include both card and battery. Consider randomly selecting a buyer and let A be memory card purchased, B be battery purchased. Then probability A is 0.6, probability B is 0.6, and probability both purchased is 0.3. It is given. Given that the selected individual purchased an extra battery, the probability that an optional card was also purchased is, given that a person selected purchased an extra battery, the probability that the optional card was also purchased is. So what is the probability we need to find out? The probability that an optional card is purchased given that an extra battery is purchased. So optional card means memory card is purchased is event A. That means I want probability event A given that the selected individual purchased an extra battery. Extra battery is event B. I have written it as event B, battery purchase, right? So we need to find out the conditional probability A condition to B. That will be probability A intersection B upon probability B. Now what is provided to us is that intersection is 0.30. So 0.3 upon what is the probability of B? It's 0.4. That means 3 by 4 is the required probability. That essentially means that 75%, this means that 75% of people buying extra battery are also purchasing extra memory card, optional memory card. That's what it means. Similarly, you could also have been asked a question where you had to find out what is the probability B conditioned A. That is, of all the people buying extra optional memory card, how many are also buying the battery? That would have been probability A conditioned B upon probability A. So that would have been 0.3 upon 0.6. That is 1 by 2. 50% of the people, that means 50% of the people who were buying, um, who are buying the memory card are also purchasing actually extra battery. And that's how conditional probabilities are to be solved. This is a very interesting concept and used widely in probability, and it is associated to the Bayesian probability Bayes theorem, which we will be learning pretty soon. Thank you very much.